Hello folks, welcome back to Merrill Math. I'm Mr. Merrill, and today's topic is polynomial long division. So we're dividing polynomials today. One thing I want to get out of the way really quick is polynomial long division is exactly the same as the long division you might have learned in, I guess it would have been about maybe 4th or 5th grade. Exact same thing, except it just looks a lot more complicated. So if somebody gives you a problem like, what's 124 divided by 7, that type of problem, the way you would solve that is the exact same way that we're going to attack these polynomial problems. So it's the same algorithm. We take it into the first digit. Well, it doesn't go into that, so we'd say, well, 0 times for there. But 7 does go into 12 once. So we take 1 times 7, that's 7, and we subtract. 12 minus 7 is 5. And 7 doesn't go into 5, so we're going to go ahead and bring this 4 down. Does 7 go into 54? Yes, it does. Not 8 times, but 7 times. And 7 times 7 is 49. And we subtract. 54 minus 49, that's going to be 5. So our remainder is 5. So we could say it's 17 remainder 5. But a better way to say that is it's 17 and 5/7. So we can make our remainder into a fraction. So that is what we're going to do for our polynomial long division. So without further ado, let's take a look at one of these guys. So here we have a much more complicated looking problem, but the steps that we're going to follow is exactly the same. So we're going to take, it's not this entire x plus 6 into this first term, it's just the x. So we're taking the x into this, and then we multiply, and then we subtract, and then we take the x into that. So then we multiply and subtract, multiply and subtract. And if we have a remainder, we can deal with the remainder at the end there. And sometimes there might be some simplifying that we can do with the remainders, but we'll cross those bridges when we get there. So how do we do this? Well, we're going to take the x into 2x to the third power. So if I wanted to multiply this by something to get this, what would that be? Well, 2 is going to be a part of that because there's no 2 here. So 2 and x squared times x gives me x to the third. So I'm going to say x squared. So now I take this and I multiply it here. And what do I get? Now notice when I multiply 2x squared, I'm going to multiply this and this. So what do we have? Well, 2x squared, that's going to be 2x to the third. And we'll notice that this is going to cancel out, which is good, because that's what we want. We designed this to specifically be equal to that, so it works out that way. And 2x squared times 6, so 6 times 2 is 12. See, I said 12, not 13. I saw 13, tried to write it. Okay, so 6 times 2 is 12, and that's going to be x squared. So what we're going to do is we're going to subtract. So this is gone. This cancels out. So what we're left with is 13 minus 12. So we have x squared. And we're going to bring this down to the 9x. So plus 9x. Okay, so what do we have? Well, it looks like x into x squared. That's going to be just an x. So we're going to say plus x. And then x times this, that's x squared. X times the 6, that's going to be 6x. And subtract. Notice this cancels out. So now we have 9x minus 6x. That's going to be 3x. Okay. So we're going to go ahead and pull the 18 down here. So plus 18. And we're going to say taking x into 3x. So x times what equals 3x? Well, x times 3 equals 3x. So we're going to say plus 3. And multiply. So 3 times x, that's 3x. 3 times 6, that's 18. And we're going to subtract, and lo and behold, we get 0. So there's no remainder. So what does that mean? Well, taking a look back at where we started, when we do division, well, what does division mean? Well, that means that if 124 divided by 7 equals 17 and 5/7, then I could say 17 and 5/7 times 7 equals 124. Some easier numbers to work with here. 20 divided by 4 equals 5. So we know that 5 times 4 equals 20. So that's sort of how we define division is in terms of multiplication. So what can we say about this? Well, we can say x plus 6 times 2x squared plus x plus 3 equals 2x cubed plus 13x squared plus 9x plus 18. And this is one of the great things about algebra, and one of the things I always tell my students is there's never an excuse to get a wrong answer, because when we come up with something like this, 2x squared plus x plus 3, when we come up with something like this, we can check our answer. And if we go ahead and multiply these out, we'd have to FOIL them. But if we multiply those out, we would get this. So you can multiply those out on your own and double check that. But I'm pretty confident in my work, so let's move on. Okay, let's look at a second example here of this polynomial long division. Now, before we get started on this one, I do want to point out our terms here. We have 8x cubed minus 6x squared plus 0x minus 40. Some of you might be asking yourselves, why the 0x? Well, this is actually a necessary term. We have to have that little space filler here because we need to have all of these x's, the 3, 2, and this is x to the first power, 3, 2, and 1, accounted for. If it was x to the fourth, third, second, first, we have to have all of those accounted for, and our constant. So the 0x, very, very crucial. If you leave that out, you're gonna have a bad time. Okay, so same process as before. We're taking the 2x into this. Actually, now that I look at this, I notice there's a shortcut. And I may or may not make a second video on a shortcut. A lot of times when I'm teaching things, I'll notice that there's easier ways to do stuff, but then that just ends up confusing people. So let's not do that for right now. And if you're curious, leave a comment, and I might go over that. Okay, so 2x into x to the third. So we're going to take 8 and divide it by 2. That gives us 4. And x cubed, we're going to divide by x. And that gives us x squared. Now we multiply, so that gives us 8x cubed and 4x squared times a minus 6. Now this minus sign goes with that. 4x squared, so 6 times 4, that's 24. So it'll be minus 24x squared. Now we subtract. So the x cubed terms cancel out, but notice this, we have a negative 6x squared minus a negative 24. Now when we subtract a negative, that's the same as adding a positive. So what we have here is negative 6 plus 24, which gives us a positive 18x squared. Now we're going to bring our 0x down, our all-important space holder, and we divide again. So 18 divided by 2, that's going to be 9. And x squared divided by x, that's going to be x. So now we multiply. So 9x times 2x, that's going to be 18x squared. And 9x times a minus 6, that's going to be minus 54x. Okay, now we subtract. Notice here we're subtracting a negative again. So our x squared terms cancel out, and we're left with a positive 54x. We're going to bring our minus 40 down and divide again. So we're going to take 54x divided by 2x, so 54 divided by 2, that's 27. X divided by x, that's 1. 27 times 1, that gives us 27. So now we have to multiply. So we're going to say 27 times 2x, 54x. 27 times 6, that is, I believe, 162. So we're going to say minus 162. And we're going to subtract. So here we have negative 40 minus a negative 162. Negative 40 minus a negative 162. So what that amounts to is negative 40 plus a positive 162, or we could just say 162 minus 40. So there's a lot of different ways we can think about this problem, but these cancel out. And this, we're left with a positive, looks like 122. Okay. So what do we do with that? Well, that is our remainder. Notice that 2x will not go into this because there isn't an x. So this is our remainder. This is what we're left with. So we could call that, let's deal with our remainder down here, 122 over what our divisor was. That's 2x minus 6. So 2x minus 6. And one of the things I noticed at the beginning was all of these are even. 0 is also even. So we could have started out by dividing everything by 2. But here, we notice we could leave it like that, but technically it's not correct. So we want to simplify this down some more, because this is even, that's even, this is even. So we can divide everything by 2. So half of 122, well, that's going to be 61. And half of 2x minus 6, half of 2x is x, half of minus 6 is minus 3. So when we come back to the top and we deal with our remainder, we call that plus 61 over x minus 3. So that's our answer. And that is it for now for polynomial long division. If you have any questions, leave them in the comments. If you have any suggestions for future videos, also leave that in the comments. I'm always looking for new ideas. So if you have anything you want to learn, let me know. Thanks for watching.